Hello and welcome back guys with a brand new video, and today we are diving into the world of electronics and exploring the fundamentals of low pass filter and specifically the RL configurations. Before these topics I have already discussed about the low pass, high pass, RC circuits, and also about the high pass RL configurations. Now we are moving towards for the specifically the RL configurations. Whether you are a beginner or an enthusiast, understanding how these filters work can be a game changer in electronics, and you are at the right place. First off, what exactly is a low pass filter? Well, it's a circuit that allows signals with a frequency lower than a certain cutoff frequency, as you can understand by its name, to pass through while attenuating frequencies higher than that. In the RL configuration, we are dealing with a combination of a resistor and an inductor. And if we uh, move towards and break down the RL circuits, we have a resistor and an inductor in series. The resistors which opposes the flow of current, and the inductor which resists changes in the current passing through it. When combined, they create a filter that can pass low frequency signals while impeding higher frequencies. Now let's talk about this circuit behaves concerning different frequencies. As you can see here, at lower frequencies the inductor's reactance is low, allowing these signals to pass through with minimal opposition from the resistor. However, as the frequency increases, the inductor reactance increases, leading to a greater opposition to the flow of current. You can easily understand by watching these a waveform of a sweep log and the output that what it's working. I will also explain this. However, as the frequency increases, the inductor's reactance increases, leading to a greater opposition to the flow of current. As graphically represented here, the frequency response of the RL low-pass filters, it showcases the ability to pass low-frequency signals nearly unaltered while attenuating higher frequencies. This response is crucial in applications where certain frequencies ranges need to be filtered out. As you can see, its name is low pass filters. As we discussed in our previous video of low pass filter with RC configurations, I have explained this graph. You can also visit using the same playlist to check out, and other I will also explain it here. That you can see I have also explained in that video about the frequency, that how the frequency work here. If let me make it a larger one, you can see here now that as the frequency is increases, you can see here what is frequency. Basically, frequency is the number of cycles and 1 second or unit second. You can see here it's not allow the filters to pass out it, and as the frequency again low down, so the low pass filters allows the signal to pass out. And so, where do we find RL low pass filters in the real world? You can say applications. They are commonly used in audio systems to remove unwanted high frequency noise, and power supplies to smoothen out voltage ripples, and in various communication systems for signal conditioning. And there you have it, a brief overview of RL low pass filters. Understanding how these components interact in a circuit helps us manipulate signals to suit specific applications. And if you require any type of assistance in your electrical and electronics projects, assignments, tutoring, you can ping me a message on my WhatsApp number, and also you can visit my Upwork and Fiverr profile. Thank you so much for watching the video. Please like the video and share the video with your friends. Thank you.